All right. Hey everyone, we're here to finish up this set of notes. And so we're going to finish up talking about finding areas between curves. Just to remind you what we're looking at, our idea is to get the top curve minus the bottom curve. Or since we have x in terms of y this time, so we solve for x, now we want the right curve minus the left curve. Okay, and so hopefully it's pretty clear that here's your right curve and here's your left curve. Okay, so that means when we write our integral, it should be right curve minus the left curve. Which will be the red curve minus the blue curve. dy, because we're integrating in terms of y. Okay, now we need to solve for what the bounds are, because we need to know what to integrate this from. So that's just going to involve setting these two equations equal to each other. I think we did most of this in class, but just to refresh our memory of what we're doing. So we'll set this equal to 0 and then solve. So we get -3 and 2 as our boundaries. So that's what we're going to set our bounds to. Our bottom bound is going to be -3. And our top bound is going to be 2. Okay. So now we're going to do simplifying, take the antiderivative, and so on. Integral. Okay, this should give us 125/6. Again, I think we did most of this in class, but just want to make sure we have everything. Okay, so that's an example where we're putting everything in terms of y. And if we're putting everything in terms of y, then it's going to be the right curve minus the left curve. Most of the time, it's top curve minus bottom curve. Okay, so let's move forward with the last one. Next one. Again, this is going to be here's my red, and then this one's going to be my blue. Okay. So again, we need to figure out what is our top curve and what is our bottom curve. Well, y = 1 is just a horizontal line at 1. And if you're thinking that's not great, you should have seen my first 2 attempts at this. Here we go. Cosine squared. Well, cosine squared, we know that range of the cosine graph is between -1 and +1. Okay? Doesn't dip below -1, doesn't dip above +1. If I square that, then we know that the range of this is going to be between 0 and 1. Okay? If I have my range limited from -1 to 1 and I square that, then I'm not going to go above 1. Okay? So what it's going to be doing, I know it's 0, that it's 1. Okay? And I know any place like at pi/2 that it originally hit 0, it's going to hit 0 again. But then the difference is that it's going to bounce back up to 1 instead of going down to -1. Okay, so it's going to look something like this. Again, the key idea here is that it bounces between 0 and -1. So if I want to find the area between these two curves, then the area that I'm finding is here. Here's the area between these two curves. Okay, integral. Top curve minus bottom curve. Well, my top curve is just 1. It's the horizontal line. So my top curve is 1 minus your bottom curve. Well, the bottom curve is the cosine squared of x. Now I need to know what my bounds are. So I need to know when 1 equals cosine squared of x. Well, that's going to be everywhere that cosine, if I take square root of both sides, that'll be everywhere that cosine is positive 1 or negative 1. Okay? So if I'm looking in this area, the first time cosine hits 1 is at 0. Okay? And then if I go through my cycles at pi over 2, it's at 0. And then at pi is the next time cosine is positive or negative 1. So x equals 0 is my first point, and x equals pi is my second point. So that's what I'm integrating from. I'm integrating from 0 to pi. Not bad. Okay. Oh, if I want to integrate this is fun. So, this is the same. This is the same as the integral from 0 to pi of, well, 1 minus cosine squared. Hopefully you know that's sine squared. Okay, and then bad news. We still don't know how to integrate sine squared. So doing this by hand would actually involve using a trig identity. It involves a double equal formula, which is this one. Which also equals, if you use, I don't want a cosine squared because I'm just interested in sine squared. So it equals 1 minus 2 sine squared x. And so solving, so now if I solve this for sine squared, we get 1 minus cosine of 2x over 2. And now we can take this antiderivative. From 0 to pi. All right, and I won't show all the details of that. You should be able to do that yourself, maybe with a u substitution. I'll tell you what you should get. If you're doing it right, you should get pi over 2. Okay, so to back up our ideas and our steps to follow here are, first off, we're going to draw a picture and see which one's top curve and which one's bottom curve. And then we're going to set the equations equal to each other so we know what the bounds are. And then from there we take the integral. But it's always going to be top curve minus bottom curve, or if you're doing it with y in terms of x, that's going to be top curve minus bottom curve. If it's x in terms of y, like this one was, then you're going to be doing the right curve minus the left curve. But it's that same idea. Find your intersection points and then take your integral. All right? Next time soon, we're going to talk about cross sections. We're actually almost done covering everything that we would need to cover. All right? So we're getting there. Take care, and I will talk to you more soon.